Welcome to Everything About Robotics Explained.
Imagine simply telling a robot to perform a task, like, please pick up the blue box and place it on the top shelf. It sounds like something straight out of science fiction, doesn't it? But what fascinating processes allow a machine to understand and then act upon such a human command? Robots achieve this by employing a sophisticated field known as natural language processing, or NLP. This technology allows them to interpret human language, whether spoken or written, and convert it into a structured, machine-readable format that they can then map to specific physical actions. It is the bridge between our intuitive commands and their mechanical execution. This process begins with breaking down your spoken words into discrete components. The NLP system performs what is called lexical analysis, identifying individual words, and then syntactic analysis, which looks at sentence structure. But the real magic happens in semantic analysis, where the system extracts the meaning and intent behind your words. For instance, it identifies the verb as the desired action and nouns as the objects or locations involved. Intent recognition is crucial here. The robot must determine if you want it to pick up, move, or identify something. Alongside this, entity extraction identifies specific items like the blue box or the top shelf and their properties. This interpreted information is then cross-referenced with the robot's internal knowledge base, often called a world model, which contains information about its environment and its own capabilities. This allows the robot to understand your command within its operational context, navigating the inherent ambiguities of human language. The journey from your voice to a robot's action typically follows several stages. First, speech recognition software converts your spoken words into text. Next, the NLP engine processes this text, performing the analysis we just discussed. This process command is then mapped to the robot's library of predefined action primitives. These are the basic, fundamental movements and operations the robot can perform, such as grasping, reaching, or moving linearly. Finally, the extracted parameters, like the object's color or a precise location, are used to specify how these primitives should be executed. A core concept in this domain is grounding natural language. This refers to the challenge of linking abstract human language to concrete, physical actions and objects in the robot's environment. It is about ensuring the robot understands not just the words, but what those words mean in its physical reality, including spatial relationships and object properties. When a robot successfully grounds a command, it can then execute it reliably, even if the command is slightly ambiguous or phrased in an unexpected way, by leveraging its world model and understanding of context. By seamlessly integrating natural language processing, robots are becoming increasingly intuitive and adaptable partners. This blend of linguistic understanding and physical execution unlocks a new era of human-robot collaboration, making complex tasks simpler and more accessible. It enables robots to move beyond pre-programmed routines, responding dynamically to human instructions and making our interactions with them much more natural and effective.
If you love robotics, like, subscribe, and keep building with us.